Okay, let's take a look at a few examples from the even homework problems. They're similar to odd ones that you're assigned. The first one is an indefinite integral. The second and third ones have limits like 0 and 4, or 0 and pi over 3 that we'll have to plug in at the end, but let's tackle number 10 first. And number 10 isn't too bad in the sense that all three of the pieces that we have to integrate fit our table of integrals pretty directly. So remember that table from page 406 if you've forgotten it. And for number 10, we'll just say the integral of x squared is 1/3 x cubed. The integral of 1 is x. And 1 over x squared plus 1, again, that's not an... You can't integrate the top and the bottom separately. This is one piece, and it has to fit one of our things on the table, or else we don't know what to do, because we don't have the inverse quotient rule yet. But fortunately, if you look at this table of integrals down at the bottom, in the bottom left corner, 1 over x squared plus 1 is the derivative of inverse tangent. So we're in good shape right there. The last bit will be a plus inverse tangent of x. And because this is an indefinite integral with no limits, we'll put a plus c on the end. Okay, and that's it for number 10. So let's move on to number 22, and I'm going to go ahead and erase this one. So 22 is not in one of the forms from the table. It's a product, and we don't know this sort of anti-product rule, the antiderivative for products. But fortunately, again, some algebra will help us out here. So I'm going to do a little bit of algebra before I actually start doing any calculus. And I'm just going to multiply this out. This is a FOIL. So multiplying the first terms gives me 6v squared, and then I get 15v minus 2v, so 13v total, and minus 5 on the end. And the variable of integration is v, which is good. And now we're in pretty good shape. Right? We can integrate this thing. Keep in mind the 6 will just sit there, but v squared would go to 1/3 v cubed. Again, the 13 is a constant multiple, but v would integrate to 1/2 v squared. And the minus 5 will go to minus 5v. And we are integrating that from 0 to 4. So we need to plug 4 into all of this and then subtract what we get when we plug 0 into all of that. So let's go ahead and plug in 4. Let's see, that'd be 6 times 1/3 times 4 cubed, which is 64. So it times 64 and 13. When I plug in 4 for v, I'll get 1/2 times 16 and minus 5 times 4. Okay, all that was just plugging into 4. We still need to do minus and plug 0 into all of this. Fortunately for us this time, plugging in 0 to each of these terms gives you 0. So this all just ends up being 0, which is nice. We still have to crunch some numbers over here on the left-hand side. So let's see, 6 times 1/3 is 2. Times 64 is 100. This is really the time you should grab your calculator, by the way. But 128. 16 times 1/2 is 8. 8 times 13. Oh boy, let's see. 8 times 13. I think I do need to grab my calculator. 8 times 13 is 104. I knew that. Of course I knew that. 104 And then 5 times 4 is 20. And we still got the minus 0 on the end. So let's see, 128, 228, 232 minus 20 is 212. 212. Okay. So I think the area underneath this curve from 0 to 4, or the total amount of change in whatever this is 212. Okay. So let's go ahead and erase that one. And we will move on to the final one. So the last one looks like it's also going to need some algebra. It isn't sitting right in the form that we need already. So let's go ahead and tackle that. I'm going to start over here on the left side, give myself a little bit of room. So 0 to pi over 3. And this already looks like I'm probably going to need to split it up into separate fractions, so I'm just going to do that as I write it down. We'll do sine theta over secant squared theta plus sine theta tangent squared theta all over secant squared theta. And d theta is on there to remind you what the variable is. So I'm hoping these two things will simplify down into things I actually know how to integrate. So let's see if we can work that out. Keep in mind that secant is 1 over cosine. So when we work on that, let's see, we've got sine theta. This is really 1 over cosine squared. So let me skip down one more line. And when you flip that fraction on the bottom and multiply, you get sine theta times cosine squared theta. And I'll do the same thing over here on the other integral. I'm going to flip it over and we'll get sine theta tangent squared theta times cosine squared theta d theta. Keep in mind that tangent is the same thing as sine squared over cosine squared. So I already like that because there's a cancellation. The tangent has a cosine squared on the bottom, so this cosine squared and that cosine squared end up canceling. And we end up, let's see, let me go back. We end up with sine theta times sine squared theta. And the other one, I'm not sure exactly what to do with yet. I've got sine theta cosine squared theta. So at this point, we'd probably be stuck, except I'm noticing something that's setting off a little alarm bell from trig. A sine squared and a cosine squared. And so let me take one more step and let me factor. I can pull a sine out of both terms here, and what's left is a cosine squared theta plus a sine squared theta. And now I'm starting to smile. Because I know that sine squared theta plus cosine squared theta is a trig identity. That's the same thing as 1. So this whole integral, man, we're finally getting there. This whole integral is just sine theta times 1 d theta. And I've actually been leaving the limits of integration off, but it's 0 to pi over 3. So really we're just integrating sine. And if you remember the integral of sine, would be negative cosine. The derivative of cosine is negative sine. So we need an extra negative on there, and we'll evaluate that from 0 to pi over 3. So we have integrated. We just need to plug our limits of integration in. So we'll get negative cosine of pi over 3 minus negative, and be careful with your negative signs here. There's a lot of them running around. Minus negative cosine of 0. So you might have to go back to your trig or to your calculator to remind yourself what cosine of pi over 3 is. But that cosine of pi over 3 is 1/2. So this is negative 1/2 minus, and cosine of 0 is 1, so minus negative 1. So negative 1/2 plus 1. So all that work, a full page of work just to get that 1/2 is the area under the original function from 0 to pi over 3.